We've talked a lot about the Condorcet winner. This is a candidate that beats every other candidate in a head-to-head election. And we've suggested, a number of people have suggested, that if a Condorcet winner exists, then that person should be elected. That's the best reflection of what it is that a group of voters actually want. Now, we've seen one of the main problems with the Condorcet winner is the so-called Condorcet paradox, which shows that there are situations in which the Condorcet winner doesn't actually exist. What I want to look at now in this lecture, in this short lecture, are arguments why we might not actually want to elect the Condorcet winner, even if that person, if the Condorcet winner exists. So the question is, should we always elect the Condorcet winner? So let's start by looking at an example. So this is an example of 100 voters. And in this election, what we can see, if we look at the election data, so these are the rankings that we've collected from the voters, from all 100 voters, we see that there are 94 people that rank A first or B first, and they're split between A and B. So everybody's completely, in the head-to-head election in A versus B, it's completely split. But A and B have an overwhelming support of the population. So 94 people rank either A first or B first. A small group ranks C first. 6 people rank C first. But because these 94 people all strongly agree that, or all agree that C should be ranked second, C turns out to be the Condorcet winner. So when C goes up against A, C beats A in a head-to-head election 50 to 47, and similarly C beats B in a head-to-head election 50 to 47. So C is declared the Condorcet winner. However, one way of understanding what's going on in this election is to note that what could be happening is this group here, this group of 94 voters, what they're doing is, rather than the fact that they rank C second, rather than interpreting that as positive support for candidate C, rather you can view this as saying, I want to make sure that the main rival of my favorite candidate is not actually elected. So in this group here, for example, the first column, candidate A is the favorite candidate, the top candidate. B is the main rival to candidate A. So the fact that all of these people rank C second could be sending the signal that I really don't want my main rival to be elected, namely candidate B. So you disapprove in some sense of candidate B. Similarly, this group could be saying, rather than giving positive support to candidate C, what you're really saying is that you don't want candidate A to be elected. So rather than viewing this election as suggesting that candidate C should be declared the winner because C is the Condorcet winner, we should say what's really going on is that there's 2 main candidates. Everybody supports either A over B, but the population, the voting population, is just split between A and B. And the fact that C is the Condorcet winner is not an indication that C should actually be elected. Now, of course, I'm stretching the story here. There's no way to possibly tell just by looking at this data, at the rankings, whether or not that's what is actually going on. That the fact that there's C is the Condorcet winner is the indication not of support of C, but rather there's an indication that the supporters of the main 2 candidates want to hurt the main rival as much as possible. So it's impossible to tell just based on this ranking, but at least it's consistent with these rankings right here, and it suggests that there may be situations in which we may not want to elect the Condorcet winner. So let's look at another example, and this will be a little bit more of a rigorous argument as to why we might not want to elect the Condorcet winner. This is a famous example from Condorcet. It's an example of 81 voters. And in this election, according to Borda, candidate B is declared the winner. So the Borda ranking is B above A above C. Here are the Borda scores for all of the candidates. We see that B gets the highest score. you can pause the video and double check that my calculations are actually correct. According to Condorcet, A is declared the winner. So this is yet another example of a situation in which the board account gives one winner and Condorcet gives a different winner. So A is the Condorcet winner. Candidate A beats both B and C in a head-to-head election. So you might want to pause the video and double check that that's actually the case. And B also beats C in a head-to-head election. So there's no Condorcet paradox or anything. What happens here, there's a Condorcet winner and it's candidate A. So the question is, should we elect candidate A or should we elect candidate B? And here's an argument from Don Sari. So it's an interesting argument that suggests if we just look at the data in this election in the right way, we can see that in fact candidate B should be declared the winner. So the argument relies on this following intuition, that if a group of voters can be set aside and we can see that they form what's called a Condorcet triple, and in the case of 3 candidates, there's going to be exactly 2 Condorcet triples. And so if we have a group of voters and they're split, they can be set aside and see that they have these particular preference orderings, these particular rankings, and the size of the groups are exactly the same. So G1, G2, and G3 have the same number of voters in them. So in this case, what we want to say is that this group of voters cancel out each other's votes. So taken together, taken as a whole, what they have the effect of doing is just canceling out each other's votes, so there's no distinction we can make between the 3 candidates, A, B, and C. Similarly with this other Condorcet triple. So the idea is that we might be able to look at the election and see groupings of voters that all cancel out each other's votes. And if we take that group and we factor it out, we set them aside, then we go back to the main data and we try to see, well, who wins the election without this group of people that are sort of messing the decision problem up for us because they all cancel out each other's opinions. So let's go back to the original election and try to do that. See if we can extract out groups of voters that each cancel out each other's votes. So we can do that. There's 2 ways we can do that. We can find a group of 30 people, so 10 people from this first column, and then these 2 columns of voters, that each cancel out each other's votes. So their votes taken together, or their rankings taken together, I should say, their rankings form a Condorcet triple. We can pull out another group of 3 voters, so 1 from this third column here, and then these 2 columns. And they also form a Condorcet triple, so they cancel out each other's votes. So there's a group of 33 voters altogether, so a group of 30 and another group of 3. And we can see that those preference profiles taken together all cancel out each other. So we take them out and set them aside. And of course, I'm not suggesting that we're ignoring those voters' opinions, but rather we're just looking at the data from the right angle. We're manipulating the listing of everybody's rankings to get a better handle on who should be declared the winner. If we do that, if we remove these groups of 33 voters, we see that we're left with 2 rankings. 20 people with the ranking A above B above C, and 28 people with the ranking B above A above C. And here, everybody's intuitions should point to candidate B being declared the winner. So this is at least one way to look at the data, look at the original data, and to say, well, if we factor it out in the right way, we can see that candidate B should in fact be declared the winner. So it's another example, a bit more rigorous of an argument, why, at least in this case, we may not want to elect the Condorcet winner, which is A in this particular case.